The possibility of life existing elsewhere in the universe is becoming increasingly likely, especially with recent revelations sparking intrigue among scientists and space enthusiasts alike. Bill Nye, the renowned science communicator, recently caused a stir when he revealed that Voyager 1 had detected 300 massive objects in space. This discovery has not only captured the public's imagination but also raised significant questions. What are these objects, and where do they come from? Voyager missions have provided some of the earliest and most remarkable insights into our solar system. Despite their initial expectations, these missions have far exceeded their original goals. Launched in the summer of 1977, Voyager 1 and Voyager 2 were originally tasked with exploring Jupiter and Saturn, successfully completing their mission and continuing beyond. Voyager 2, in particular, made groundbreaking flybys of Uranus in 1986 and Neptune in 1989, which earned the mission the nickname Voyager Grand Tour. However, the Voyager spacecraft didn't stop there. Instead, they set their sights on a much bolder objective: deep space exploration. Over 46 years later, both Voyager 1 and Voyager 2 continue to travel, sending back critical scientific data from the farthest reaches of the universe. In 2013, NASA made a historic announcement. Voyager 1 had officially entered interstellar space, the region beyond the influence of the Sun's particles and magnetic fields. Voyager 2 followed suit in 2018, traveling a staggering 17.7 billion kilometers away from the Sun. Remarkably, Voyager 1 and Voyager 2 are the only spacecraft to have ventured into interstellar space, serving as our primary source of information about the heliosphere, our solar system's protective bubble shaped by the solar wind. These missions have been instrumental in studying how the interstellar medium interacts with the solar wind, providing essential data about the boundaries of our solar system, known as the heliopause. One fascinating discovery from the Voyager missions is that cosmic rays, mysterious particles from space, are up to 3 times more intense beyond the heliopause compared to within the heliosphere. This shift is similar to the difference between a quiet backyard and the bustling activity of a busy street. But there's more to this cosmic mystery. In 2023, a remarkable finding occurred when Voyager 1 detected a faint humming sound matching the vibrations found in gas particles drifting in the void of interstellar space. Dr. Nikki Fox, head of NASA's Heliophysics division, emphasized the significance of these findings. She noted that over the past few decades, the Voyager missions have transformed our understanding of the Sun and its influence in ways no other spacecraft could. Despite the challenges of working with power systems fueled by aging plutonium, which gradually loses its energy output, Voyager 1 and Voyager 2 have continued to function far beyond expectations. NASA scientists faced difficult decisions to shut down non-essential systems, even including the heaters that keep the spacecraft's instruments warm in the freezing depths of space. Surprisingly, all 5 scientific instruments on both spacecraft have continued to operate well into 2019, defying assumptions about the spacecraft's lifespan. This enduring performance adds another layer of mystery to their incredible journey. On the outer edges of our solar system, there's another unexpected phenomenon. The heliopause, the boundary between the Sun's influence in interstellar space, is not stationary. Instead, it's shifting and changing shape in ways that have left scientists puzzled. For over a decade, researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer (IBEX) have observed these strange movements, prompting new theories and studies. This dynamic behavior of the heliopause challenges our understanding of space and the boundaries of our solar system. Dr. Eric Zirin, a space physicist at Princeton University, shared his excitement about these findings and how new data from the IBEX satellite is helping scientists improve their predictions of the heliopause's future movements. This research is ongoing, and with each new discovery, we are getting closer to understanding the cosmic boundaries that define our place in the universe. The Voyager spacecraft, trailblazers of space exploration, are currently making their way into interstellar space, bidding farewell to our solar system as they continue their eternal journey among the stars. Each spacecraft is roughly the size and weight of a small car, serving as a rare testament to the spirit of space exploration in the 1970s. While their computer systems are far less advanced than today's digital devices, and their analog cameras may seem primitive by modern standards, their impact on our understanding of the universe is profound. Thanks to the Voyager missions, We've unlocked incredible knowledge about planets like Jupiter, revealing it not as a peaceful giant, but as a world full of violent storms, a shimmering aurora at its north pole, and 3 delicate rings more complex than previously thought. Saturn also astonished us, as its rings, once believed to be sparse and simple, were found to be made up of thousands of intricate strands. Voyager also discovered active volcanoes on Jupiter's moon Io and Neptune's moon Triton, where nitrogen geysers erupt at temperatures as low as 40 Kelvin. The most extraordinary discoveries, however, were the potential hotspots for alien life. 2 of Jupiter's moons, Europa and Saturn's Enceladus, appear to have vast salty oceans beneath their icy surfaces, which could harbor life. These moons have become prime candidates for future exploration. The Voyager mission bid a heartfelt farewell in the 1990s, capturing one of its most iconic images, a picture of Earth from over 100,000 times farther away than our planet's surface. This image, called the pale blue dot, was inspired by Carl Sagan, a leading member of the Voyager imaging team. Sagan envisioned this view to help us see Earth in the vastness of space, to reflect on our place in the universe, and to realize that we are all connected. This perspective had never been captured visually until that moment. The image was inspired by the famous Earthrise photographs taken during the Apollo missions, particularly the Apollo 17 shot taken from the Moon's surface. On August 25, 2012, Voyager 1 made history by crossing into interstellar space, 11 billion miles from the Sun. Remarkably, it continues to send vital data back to Earth. Its twin, Voyager 2, joined the interstellar journey in 2018. At their current distances, it takes over 22.5 hours for a signal to travel from Voyager 1 to Earth and nearly 19 hours from Voyager 2. These brave spacecraft are moving farther away each day, adding another 3 to 4 light seconds to their distance. NASA's Deep Space Network, consisting of 3 tracking stations strategically placed around the world, plays a crucial role in maintaining communication with these distant probes, ensuring we can still receive their faint signals. Despite the difficulty in capturing these weak signals, due to interference from Earth's own radio, TV, and mobile phone transmissions, the Voyager spacecraft continue to send valuable data as they explore the uncharted regions of space. The Voyager mission is widely regarded as one of humanity's most significant achievements in space exploration, involving nearly 10,000 people. Remarkably, it almost didn't happen. The mission's success was largely due to a fortunate discovery by Michael Minovich, who realized that spacecraft could gain speed by using the gravitational pull of planets to slingshot them into outer space. This idea, expanded upon by Gary Flandreau, made it possible for the Voyager spacecraft to reach the outer planets much more quickly than initially planned. The Voyager spacecraft were equipped with advanced instruments like cameras, spectrometers, sensors, and magnetometers, all powered by nuclear energy. While they were originally designed to last only 5 years, they have far exceeded expectations, continuing to operate long beyond their intended lifespan. The mission has become a legendary fusion of science and storytelling. A defining feature of the Voyager spacecraft is the golden record each one carries, a collection of sounds and images of Earth, intended as a message to any potential extraterrestrial civilizations. This record reflects humanity's deep curiosity about the universe and our desire to understand our place within it. The Voyager discoveries extended beyond our solar system, including revelations about the Sun's powerful nature, its solar wind, and the protective heliosphere it creates. NASA continues to work diligently to keep the spacecraft operational, sending updates using a form of coding that ensures their continued functionality, even at these immense distances. The Voyager missions also inspired future space missions like Galileo, Juno, and Cassini, and they have helped shape our understanding of exoplanets. Today, even as the spacecraft become dormant in the 2020s, their journey through space continues. In about 300 years they will enter the Oort cloud, and in 30,000 years, they will leave the solar system to travel around the Milky Way for millennia. Meanwhile, NASA's Hubble Space Telescope is still making groundbreaking discoveries, such as capturing the exceptional light patterns of the distant, bending galaxy MCG 0112, D414. These discoveries shed new light on astronomy, demonstrating Hubble's invaluable contribution to our understanding of the universe. In 2014, scientists observed an unusual lighting up of energetic particles, hinting at potential inconsistencies in the heliopause. These irregularities didn't align with our existing models, much like an unexpected twist in a story. Researchers also noted significant shifts in the heliopause position over short time periods. Upon reviewing data from the Voyager 1 and 2 spacecraft, they found that this movement could explain why Voyager 1 entered interstellar space in 2012, and Voyager 2 in 2018, with a notable gap between their paths. These unforeseen behaviors not only puzzled scientists but also contradicted what was previously understood about the heliopause. A recent article in Nature Space Science referred to these anomalies as the section, indicating that they are perplexing and could spark debates in the academic community. However, the search for answers continues. Researchers are eager for insights from NASA's upcoming Interstellar Mapping and Acceleration Probe (IMAP) mission, scheduled for launch in 2025. This advanced satellite promises to shed light on the mysteries of the outer regions of our solar system. Until then, we can only speculate about the secrets awaiting us beyond the heliopause. In May 2023, Voyager 1 encountered an unusual event during its routine operations. The spacecraft's Attitude Control and Communication System (ACS), which manages its high-gain antenna, began transmitting strange data. Instead of the usual health and status reports, it sent seemingly random or incomprehensible information, akin to how someone might struggle to communicate due to electronic aphasia. Despite this, Voyager 1 appeared to be functioning normally, with stable radio signals and no apparent issues with its scientific instruments, which continued their work unaffected by the anomaly. NASA soon discovered that the ACS was operating on a computer that had been idle for a long time. The solution was straightforward. They instructed the spacecraft to switch to the operational computer for data transmission. While the issue was resolved, the cause of the initial malfunction remains unclear. One possibility is that a wrong command from another onboard system triggered the anomaly. Fortunately, the issue posed no serious risk to Voyager 1's health, and NASA is now investigating ways to prevent similar events in the future. Voyager 1 has been exploring interstellar space for over a decade, beyond the Sun's protective magnetic field, which shields Earth from harmful cosmic radiation. However, the spacecraft faces its own set of challenges. Similar to how Earth's computers can be affected by high-energy particles and solar radiation, Voyager systems occasionally experience errors from cosmic radiation interacting with its microchips, leading to small memory glitches that accumulate over time. Susan Dodd, the project manager for both Voyager 1 and 2, highlights that encountering these anomalies is part of the routine for missions at this stage. Both spacecraft have far exceeded their expected lifespans, having explored uncharted regions of space and provided groundbreaking data. As they continue their journey, the Voyagers face the unique challenge of operating with technology from the 1970s, including computers with just 70 kilobytes of memory. Despite these limitations, NASA has successfully maintained their functionality, even sending software updates across vast distances to ensure their continued operation. These remarkable spacecraft have overcome tremendous obstacles, traveling billions of miles and providing humanity with invaluable insights into the mysteries of our solar system and beyond. Their ongoing missions continue to push the boundaries of space exploration, uncovering secrets that were once beyond our reach.